Good morning, everybody. Today we're going to be talking about triangle congruence by several different new theorems. Today, or postulates rather. Today's key concepts are, we have some postulates that show how triangles can be congruent. If you look at this first diagram, these two sides of these two triangles are congruent. These two sides are congruent, and these two sides are congruent. If you have two triangles that are congruent by all three sides, you say they are congruent by side, side, side. The abbreviation is SSS. If we have two triangles like the next ones, triangle BCA and triangle FDE, we see that there's a congruent side here, there's a congruent side here, and then they have a congruent angle. That angle is between the two sides. It's included between the two sides. That means that that angle touches both those sides. Included. If they are congruent that way, we say that they are congruent by side angle side, or SAS. Now we have a third postulate. These triangles are congruent. They have a congruent side. And they have this angle that's congruent, and this angle that's congruent. And the side is between those two angles. It's not on the other side of the triangle. It has to be between the two angles. That is considered congruent by angle side angle, ASA. No, sorry. The fourth theorem that we're looking at is we have a side that is congruent, and then we have two angles that are congruent. And when you read that one, we've got angle, angle, side, angle, angle, side, AAS. That's a reason that things can be congruent. So, if we look at this information in the diagram, can we say that these two triangles are congruent? I see triangle BAC, that triangle there, and I see DCA. Are those two triangles congruent? Well, one thing that I see is that I have these two sides congruent. Well, that makes sense. That's given to us right here. Then I've got this angle and this angle are congruent. That's given to us as well. All right, well, there's no theorem that says they can be congruent by side angle. That's not true. So what else do we see in this picture? Well, I noticed that AC is right here in both triangles. So I'm saying that AC is congruent to AC. Remember, that's the reflexive property. So this segment here, segment AC, is congruent to itself. So then, if I'm looking at my triangle, I notice that I have this side, this angle, and this side. Side, angle, side. And I'm going to say triangle BAC is congruent example, they're giving us three statements here. They've got a side statement, and an angle statement. Okay, so let's see. ST is congruent to VU. ST is congruent to VU. TR is congruent to VW. TR is congruent to VW. And angle R is congruent to angle W. R and W. All right, can I say that these triangles are congruent, and by what reason? I'm seeing that we have an angle and two sides. Angle and two sides. Oops. No. Geometry people do not swear. That's a bad word. That's not congruent. We don't have that reason at all. So this is not possible. Next one. Okay, let's see how this one works out. We're given an angle statement, two angle statements. So the first angle statement is that angle S is congruent to angle Q. S and Q. The next statement is angle PRS is congruent to PRQ. PRS is congruent to PRQ. All right, well, that's only two things, and we need three in order to prove that the triangles are congruent. Well, again, take a look. I'm going to say that PR is congruent to PR. Because of the reflexive property. So I'm going to say that these triangles are congruent. PSR, triangle PSR is congruent to triangle PQR by angle, side. Excuse me. Take a look at this next one. Okay, well, let's start at the beginning. We've got two sides. EA is congruent to BD. EA is congruent to BD. Okay, that looks good. Then we have EB is congruent to BC. EB is congruent to BC. Well, I don't know what else we have here. There's no other statement here. But I can tell you for sure, I know that this angle right here is congruent to this angle right here, because those are vertical angles. So I'm going to say angle ABE is congruent to angle DBC by the vertical angle theorem, except now there's a problem. In this triangle right here, we have a side, angle side. That makes sense. That's side, angle side. In this triangle over here, we have, we've got an angle, a side, and a side. This particular triangle, the angle is not included between the sides. So we've again got this naughty word that geometry teachers don't say. So we're going to say that this is not possible. They cannot be congruent because we don't have the same congruence in both triangles. So we're going to say not possible. Okay. Another kind of question that you're going to run into is they're going to ask you, what information do you need in order to make those two triangles congruent by side angle side? So we look at the information that we're given. We are given that C is congruent to G. So we mark that in the paper. We are also given that CA is congruent to GD. CA and GD. Well, in order to make that side angle side, we need to have another angle. Angle side angle. If we want it to be angle side angle, we have to have another angle. So we need to have the included side is this, the green one here. So we need to have this angle congruent to this angle. So we need to have angle A is congruent to angle D. In the next example, they want us to have those two angles congruent by angle side. All right, so what do we got? We have that LK is congruent to GF. LK is congruent to GF. That's all we got. We need the first angle statement here. So if I'm looking at this drawing here, I'm noticing that these two lines are parallel. So I'm also noticing that this would be the transversal. Well, if that's the case, I can say this angle is congruent to this angle, can't I? Because those are alternate interior angles. So I'm going to say angle G FK is congruent to angle LKF. So we need another angle statement. Well, we had the red angles are congruent. I can also say that these angles are congruent because of they are also alternate interior angles. So I'm going to say that angle GKF is congruent to angle LFK. So now those triangles, you can't even see them anymore, but now those triangles are congruent by angle side. Now we have to figure out if there's enough information to prove these triangles are congruent. So if they are, then we write the congruent statement. Otherwise, we're not possible. All right, well, looking at the picture, I see two sides that are congruent. This one and this one. I see this one and this one. And I see F is a midpoint of EV. This is important information. If F is the midpoint, then this segment is congruent to this segment. So that means, yes, those triangles are congruent. And we're going to say triangle EJF is congruent to triangle FSB. Why are they congruent? They're congruent by side. And that's that. Now we have to decide if we have enough information here. Okay, we've got parallel lines. Take a look. Parallel lines right here. Does that help us out? Well, we've got this congruent to this and parallel lines. We need this transversal. Well, that's not going to help us out. What about this transversal? Well, that'll give us this, but it doesn't give us enough to figure out that these triangles are congruent. So what we're going to do is we're going to say not possible, and we're going to say that we need angle E to be congruent to angle D. Again, let's look at this one. We have this segment is congruent, this segment is congruent, and these two angles are congruent. Well, it looks like we got something, right? That's an angle side, nope, not possible. What do we need? We need an angle to be congruent. So we would need angle Y to be congruent to angle Z. Oh my goodness. Let's try that one more time. Angle Z. Okay. Now, I know you're waiting for the clue, so I want you to take your pencil and make a star next to this number 4, just right here. All right, so now we are at the last one. We've got this congruence here, M and P. We've got MN is congruent to NP, and I'm looking for a third congruence, and I know this one because there's an X in the middle, so I know that these two are congruent to each other, which means that we have angle, side, angle, angle, side, angle. So angle, side, angle, and we're going to name these triangles. I'm going to start with the M. So M, L, N. And I'm going to start with the P because that's the red one. P, and then I'm going to go down to O, and then I'm going to go to N. All right, cool, guys. Do you know this? Be ready to work on it tomorrow, and have a great night.